Well, howdy there, Internet students. This is Mr. Hermanson. And this lesson 8.7 is we're going to be looking at factoring some special cases. All right, and hopefully you can recognize these and see that they're pretty easy to factor once you recognize them. Okay, let's just start by doing this first problem and making our little area model. And we'll put the x squared there and the 4 there. And so we know that this is an x and an x, right? And so this is either 2 times 2 to get that 4, or it's 1 times 4 to get that 4. But we need a negative 4, and if we use a 1 and a 4, those would add up to 5. So it's got to be the negative 2 times negative 2, 1. And so we get a negative 2x, and a negative 2x makes 4. And so this can be written as x minus 2 times quantity x minus 2, or x minus 2 squared. So we call this a perfect square trinomial because we can write it as something times itself. Okay, now here's how you might have recognized that, that this is a perfect square to begin with, like, you know, numbers like 1, 4, 9, 16, which is some number multiplied by itself. And then this number right here is actually, just ignoring the negative sign for a second, is the square root of 4 times itself. So it's twice the square root of 4. So a perfect square trinomial looks like a squared plus 2ab plus b squared, which would factor like that. Or you could also, like this one has a negative, so a squared minus 2ab plus b squared. In that case, it would be a minus b times itself. And you could verify that by multiplying it out using an area model if you want. But if you do notice that, like you might on this one, kind of look at this last number. If you notice a perfect square, then you take the square root of it. And if this number is double that, it's a perfect square number. So go ahead and see what you get when you factor that. And there's what you should have got. And since you're multiplying the same number times itself, you can more simply write it like that. Okay. All right. So, so what if you notice that here? Check this out. This 16 is a perfect square. 9x squared is a perfect squared. And if you take the square root of 9x squared, that's 3x. The square root of 16 is 4. Multiply those two together gives you 12x. And then you're going to double that, 12x, and gives you this. All right, now if you were making the diagram, just to point out where all that came from, so you'd have your 9x squared here, you'd have your 16 here, and you would have your 12x twice. And the reason you have 12x twice is because the factors are both the same for that and both the same for the 16. So you get this number duplicated. So, so you can quickly factor that by just taking the square root of this, which is 3x. Take the square root of 16, which is 4. And square that, multiply it by itself. All right, why don't you try one of those? Did you get that? And you can verify it with your, until you start believing in yourself. But if I put 4m minus 9 and 4m minus 9, I get 16m squared. I get positive 81 there. I get negative 36m twice. All right. Now, there is also a situation where you multiply two binomials together and you do not get a trinomial. And that happens because these two terms add up to 0. So it's pretty easy to find the x here, right? And then you have a 64, which is a perfect square. Now the way you're going to get those to equal 0 is if you do a negative, that should be a negative 64, right? A negative and a positive. So now you have negative 8x here, you have positive 8x here, and when you add those two together, they equal 0, so you end up equaling x squared minus 64. So the factors are x minus 8 and x plus 8. Now, if you recognize that quickly, it's going to be pretty easy to factor it. Go ahead and you try this one. That's what you should have got. Now again here, so we have this, you'll notice is a perfect square. We don't have any middle term, so we need the same thing twice. Now what's going to give us that is if we use the same numbers, where one is positive and one is negative to get this 25. So we want a negative 5 and we want a positive 5. And to get the 9x squared, we want the same numbers, 3x, 3x. And when we multiply 3x times negative 5, we get negative 15x. When we multiply 3x times positive 5, we get 15x. And those two add up to 0, so it works out. So we have 3x minus 5 times quantity 3x plus 5. All right, see if you can get this one. That goes really quick when you realize you're factoring the difference of two squares. Okay, now sometimes you might have a greatest common factor involved. Like if you look closely at this, they do have a factor we can factor out first, and that is 3. So the first step I'm going to do is do my 3, and then that gives me 4x squared minus 1. And now this is a difference of two squares. So I'm going to just go ahead and write it, because now I know what's going on with this stuff. And then 1 is a plus. That's what gets us to cancel out that middle term. So there it is. So if you can factor out a greatest common factor first, make sure you do that. So it looks like these both have a common factor, greatest common factor of 12. Start by factoring that 12 out. Okay, and I'll let you finish it. That's what I'm thinking. Hope you have similar thoughts. All right. I think that's it. You can just go ahead and start working on your practice. We'll talk to you soon.